Okay, so we're modeling the situation that I laid out in the other video, and I'm going to start with the two models of the people's decision, in particular the people's decision about how vulnerable to be on the platform, because that's going to determine the quality of the platform, it's going to determine how fast the platform grows. So that's really important for the revenue of the platform and for the experience of the people on the platform, etc. And how vulnerable you are depends on whether or not you feel like you're likely to be betrayed. So this is two models. You're going to model them the same way you always do, by brainstorming what are the reasons you would be more vulnerable, what are the reasons you would be less vulnerable. Ask yourself, why is vulnerability not infinite? Why is it not zero? How do you find that perfect balance of vulnerability? And then, of course, building in any relevant variables that the managers of the platform might want to come up with. And since that's so related to betrayal, you also want to model betrayal. And I should say, there's a difference between actual betrayal and perceived betrayal. And every model is always from the perspective of the person who's making the decision that the model is modeling. But both of those actually might be relevant in separate contexts for this particular platform. Here I'm only going to model the person's own perception of, here I'm going to model a person's actual decision about whether or not to betray a friend. And just know that there might be a slight difference when someone thinks about their friend's probability of betraying them. So first let's model vulnerability. So this is my model of a person's decision about how vulnerable to be on this platform. And of course it's from the person's perspective. They're deciding their vulnerability on the platform. And why are you choosing to be vulnerable? It's because you want to experience friendship quality through the platform. So this is friendship quality experience through the platform, not overall friendship quality. There could be a difference there. And that, of course, depends on how vulnerable you are on the platform. It depends on the quality of your friendships generally outside the platform. Do you have friends that are also likely to reciprocate and be vulnerable, or are your friends less likely to reciprocate? And of course, this one is exogenous. The quality of friendships experienced on the platform also depends on the platform interface. The user interface of the platform is going to make that experience more hassle-free, more easier to use, easier to connect with your friends. A lot of the investment of the platform is going to be in making this better. So this is exogenous, but of course we acknowledge that this is going to be a choice variable for the managers of the platform. And that's what we're going to try to build into all these models, is what are the variables that connect between the different players in our modeling process. Okay, so and then why don't? Why are we less vulnerable on the platform? It's because we're afraid of betrayal. So we have probability of betrayal, which is a function of platform enforcement mechanism. And of course, this is going to be one of the key innovations of this platform, is it has a way of enforcing betrayal. So if one of your friends betrays you, there's consequences for them, and that's going to deter them from betraying you, even if they get really upset at you, or even if they feel like they could get a lot of attention if they did betray you. And the probability of betrayal, of course, is also a function of the same quality of your friendships generally. Now, you notice that this probability of betrayal is exogenous. You could probably make an argument that it might be endogenous, that I don't know if that relationship would be a positive relationship or a negative relationship. If you increased your vulnerability, would that increase or decrease your probability of betrayal? You could probably argue either way. The reason I chose to make this exogenous is to keep things simple. You don't want your models to get too complicated. You really only want the exact amount of complexity that's going to help you analyze and make the points you're going to make, and this isn't the main source of complexity. My view is that by being more vulnerable, that it's not so much about that increasing or decreasing the probability of betrayal, it's about that increasing the pain that you experience if you're betrayed. And so we have forces pulling vulnerability up, forces pulling it down, and we've got a model that connects in a couple of different places, including key places to understand the value of our platform, with variables that will appear in our platform manager's objective functions. Now, of course, this is a continuous choice variable, and we want to see a situation where you have a binary choice variable, because some of you may want to use binary variables in your models. And we also want to just model betrayal, because betrayal, the probability of betrayal, is an important force that we can derive. And so let's actually do that. We're going to model the probability that you will betray your friend by posting something private that they've shared with you through this podcasting platform. Okay, so we have our betrayal model, and this is going to be with a binary choice variable. Now, I like to set these up first with a maximization sign, so we've got our nice benefit and our cost, and it has the same structure as a normal continuous variable model, but I'll show you in a second how this can be transformed into just a straight up inequality, which is true of any binary model. They can always be collapsed into an inequality. So, what's our model? Why do we betray? What's the benefit of betraying? Well, I actually think there's a number of different reasons to betray, but two big categories of reasons. One is you might just want attention, like if you share your friend's personal struggles or their personal life with the world, you might get that attention, and attention-greedy people might love that. I'm not going to model that here, but you could model that separately. It would be pretty fun to do that. I'm going to model the situation where your friend, friendships have up and downs, you get angry with people, you get kind of annoyed with people at different times, and certain personality types can get a lot of utility from retribution of friends who they believe deserves to be betrayed or to be punished for not being a good enough friend or whatever reason. So, I've based this benefit on a retribution satisfaction term. So the satisfaction you get from retribution depends on whether or not you actually betray them, and it depends on a couple of other things too. Now, not every personality type gets this, and as a matter of fact, this might be negative for everybody, or for some personality types. Some personality types might feel horrible or feel guilty if they ever betrayed a friend, which is a great trait to have in a friend, but we're just trying to capture the risky cases. And a lot of times you may want to get to know a person before you know what they're like in their worst moods. So I wanted to multiply this by a mood coefficient, where I think mood coefficients aren't built into models enough. We kind of have up and down moods, positive and negative, and maybe different qualities to those moods. This is just an up or down term. That's what coefficients do, but like you have positive moods and negative moods, and when people switch into negative moods, I guess this would be interpreted as the strength of a bad mood or something like that. And then times I have a coefficient for neuroticism, where people with certain personality traits such as neuroticism, when they're in a bad mood, they get way more value out of retribution than other people. Now, I'm just building this in. You can argue against it. You could say, okay, that's not really a accurate reading of the psychology literature on neuroticism, and you could convince me to name this variable something else. But I do believe that this gamma variable captures something about some personality types really getting a lot, placing a heavy weight on retribution when they're in a bad mood. And so I put the neuroticism also inside the retribution function. Maybe that's a little bit overkill. As a matter of fact, now that I'm looking at it, having it in both places is almost kind of redundant. Does it belong inside or outside the equation? either one would work. I'm going to leave it outside for now. So retribution is a function of whether or not you betray them, and as a function of the vulnerability. If they're not vulnerable, it's just not going to be worthwhile to betray them. But the more vulnerable they are, the more satisfying it will be to betray that person. Okay, minus. Now here we have a term that I've defined up here. It's the platform enforcement mechanism, which is exogenous, and this is an important term because it's what the platform is using to enforce keeping things private between friends, times the personal pain you experience from the enforcement mechanism. And this could be something we might want to play around with in the future when we're thinking about enforcement mechanisms. We could really think about what personality types would experience more pain versus less pain, and does that reduce the incidence of betrayal. But I made that a function of also this neuroticism, which is maybe an incorrect usage of the psychological term, but I get to play around with the model and do whatever I want to, so I'm going to use it for now. And that's multiplied by this whether or not we betray them, which is a 0-1 variable. So if we don't betray them, there's no chance we experience the pain of the retribution from the enforcement mechanism. And we know that this is a very clean yes-no thing because of the blockchain mechanism we have for identifying the person who is betrayed by posting publicly a private conversation. Okay, so that's a very fun model of betrayal. And now, of course, once you've got two models on the board, you need to ask yourself, how do they connect? Because connecting models is part of the fun of making a series of models. So we look at these two models and we say, okay, wait a second. We know that the probability of betrayal up here, this probably should relate to people's decision about whether or not to betray, but these don't perfectly match up. This is binary, this is not binary, it's continuous probability of betrayal. And it's not really one friend, it's like all the friends you're talking with on this platform. So you might just need a little bit of a mechanism to connect those. So let me show you how that works. Alright, so here I'm just defining what this probability of betrayal is and how it relates to this model by saying each person has their own individual decision about betrayal. And so I'm giving betrayal a sub-I, meaning every person, every individual is going to solve this optimization problem for themselves. And the probability of betrayal for someone is going to be a function of the sum of the betrayal situations for all of their friends. So I equals 1 to n, where n is the number of friends that you choose to interact with in this way on the platform who have access to your personal conversations, and bi is, of course, each individual's probability of doing that. So that's just one way of connecting the different variables in this model. Now, I promised you that I would show you how to make this equation into an inequality instead of a maximization problem. So let me do that, and I'll have to erase the top part of the board to do that. Okay, to do this, we're basically going to say this is our equation, and we can write this in two ways. We can write this equation where betrayal equals 1, and we can do the same thing except where betrayal equals 0. And you'll betray them if the utility, this is the utility function, is greater when betrayal equals 1 than when betrayal equals 0. So let's write that out. Alright, so here we have, this is our utility if we betray, which is just this function where we've let betrayal equal 1 in our retribution satisfaction function minus our pain from the platform's enforcement mechanism is greater than our retribution satisfaction where b equals 0. And you could probably even simplify this to be 0, right? If you're not going to have any retribution satisfaction if you don't betray, in which case you could actually just set this whole side equal to 0. So if the satisfaction you get from betraying is greater than 0, you will betray. So here I plugged in b equals 0. You can do that, you can use that form, especially if you thought there was a reason why this function would be non-zero. In some cases that you might want to use that kind of notation, and I definitely knew this whole term was for sure going to be 0 if b equals 0. But to simplify things, and with modeling you should probably simplify as much as you can without losing key insights. Just betray if the utility for betraying is greater than 0, and it's a very simple function, but it still belongs in our system of modeling for this problem.